there. Zoe was just telling us a funny joke. Tell it again, Zoe.
What do you call an angle that gets destroyed?
What?
A rectangle!
Hi, I'm Paris from period 5.
Hi, I'm Zoe from period 6.
Hi, I'm Claire from period 5.
And we will be teaching you the 5 theorems.
How to do a proof?
And the distance formula.
The first thing we will be going over is the 5 theorems, and the first theorem we'll talk about is SAS, or side angle side. This is when 2 pairs of sides of 2 triangles are equal in length and the included angles are equal in measurement, then the triangles are congruent. This is how it looks. Here's an example. So the 2 sides are congruent and there's one angle. So side, angle, side.
The second theorem is angle, angle, side, otherwise known as AAS. If 2 angles and the non-included side of one triangle are equal to the corresponding triangles and sides of another triangle, then they're congruent. You can tell in this example that that angle, angle, side applies because it marked that 2 angles are the same in one side, so angle, angle, side.
So here is angle, side, angle, also known as ASA. If two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So here in the picture you can see it's angle, side, angle, angle, side, angle. So they're congruent, and the lines represent that these 2 sides are the same, and the arcs represent that these angles are the same size, and the 2 arcs represent that these 2 are the same.
The fourth theorem is side, 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 otherwise known as SSS. When there are 2 triangles that have corresponding sides that are also equal in length, then you know the 2 triangles are congruent. You can tell that these 2 triangles in the picture are congruent because of the amount of dashes in each side. Those sides both have 1 dash, so they're congruent. Those have 2, so they're congruent. And those have 3, so they're congruent. Since all 3 sides are congruent, they are also, the 2 triangles are congruent.
The last theorem that we will go over is the hypotenuse leg triangle, otherwise known as HL. The hypotenuse leg theorem, or HL theorem, states that if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and one leg of another right triangle, then the triangles are congruent. You can tell that this is a hypotenuse leg triangle because of the dash showing their congruence, and both triangles have a right angle. So yeah. Speaking of the theorems, I have a joke for you guys. What do you call a teapot that Mr. Farrar finds on the top of Mount Everest?
What?
I don't know.
A hypotenuse.
Now we're going to show you how to do a proof. We've set up an example of one, and it's already given that line DF is perpendicular to line GE, and that F is the midpoint of GE. We have to prove that triangle GFD is equal to EFD. The first step is pretty easy because it's already given. So we already know that that line DF is perpendicular to line GE, and that F is the midpoint of GE. So you just write that as your first step. And also, you have to make sure that when you're setting up your columns to write all the facts, you make one side for statement and one side for reasons.
So since we know that F is the midpoint of G and E, then we can already say that GF equals FE. So GF equals FE. We can also tell because of the lines that indicate they're congruent. Secondly, we say that this is the definition, def for short, of the midpoint. Then we say that lines FD is equal to lines FD because they are the same line. So FD is congruent to FD. And that's called the reflexive property.
Now for the last step, we can write what we know now, which is that line GFD, triangle GFD is congruent to triangle EFD. We know this because of the theories we previously went over. We can indicate that this is a hypotenuse leg theory because of the congruent sides and congruent right triangle angles. So it is the HL theory for short. And we can also indicate that this is SAS because side, angle, and side like we previously went over.
We forgot to mention that you write given here because it's a reason for those statements. So this should be your final answer.
Oh look, it's raining right now.
Where should we go?
We should go inside.
So now for the distance formula. The distance formula is used to determine the distance between 2 points. Like if you would determine this right here, 3, 3, and 7, 6.
First, you have to determine which of the points 3, 3, and 7, 6 are x1, y1, x2, and y2. The distance formula is something you're going to have to remember. It's d equals the square root of y2 minus y1 squared plus x2 minus x1 squared. You have to plug those points into the formula.
Now what we do is substitute them into our formula. So I'm plugging in 6 minus 3 and squaring it for y2 minus y1 squared. And you add that to x2 minus x1, which is 7 minus 3, and you square that as well. And then you get square root of 3 squared plus 4 squared. Once you solve that, you will get 9 plus 16. When you add those, you get the square root of 25, which equals 5, and that is your answer.
Hey, what does a seed say when it grows up?
What?
G on my tree.
In conclusion, we've taught you the 5 theorems, how to do a proof, and how to use the distance formula. I hope that they've been helpful.
Thank you for watching.